So, hi everyone. The use case we wanted to address with Lustre client encryption was to provide a special directory for users to safely store sensitive files. Our goals were to protect files in transit between clients and servers, and also to protect files at rest. We've been able to achieve these two goals by implementing encryption directly at the Lustre client level. So here's the outline for my presentation today. First, I will give details about the file name encryption feature that is available in upcoming Lustre 2.15. Then I will explain the current limitations of this implementation. And finally, I will talk about remaining work currently in progress in this area. Okay, let's get started. I guess you're already familiar with that. On kernel side, we rely on the in-kernel FS script if we run on a 5.4 kernel. And for previous versions, we can use the embedded LLcrypt library that is available for the distributions mentioned here. On user space side, we have the FS script tool to decide which directories to encrypt and how. And in 2.15, we are providing the ability to encrypt file and directory names. So basically, we wired up the FS script primitives in order to convert between plain text and ciphertext names. We have to support access in both cases, meaning with the encryption key, but also without the encryption key. And in this case, we need to be able to list directories, to fetch file attributes, and also to remove files and directories. So how these encrypted file names are handled? Ciphertext names are binary data. They exist in memory on the client side. And so basically, we encode those binary names before they are sent from the client to the servers. We use a custom encoding so that we escape only a few critical characters like \0 and line feed, for instance. And the behavior on server side depends on the backend file system that is being used. LDiskFS is capable of handling binary names directly. So what we do is that we decode the names that were sent by the clients, and we handed them over to LDiskFS, which means that with LDiskFS, we are able to support file name length up to name max, even for encrypted files. With ZFS, it's a little bit different. ZFS is capable of handling binary directory entries, but this requires setting an immutable ZAP flag. And it's not very possible for us to do so correctly. So in ZFS, we decide to store the encoded name. And it means, for instance, if you have an encrypted file name length of 224 characters, it's almost guaranteed that when it's encoded, it will fit in a 256 character long buffer. Now, if we have a closer look at the LDiskFS backend, our implementation is compatible with ext4, meaning that we are storing the encryption context in the same extended attribute as ext4 does. So this is the encryption.c extended attribute. And we are also setting the LDiskFS encrypt flag on disk inodes. It means that we are able to use the whole E2FS prog suite. We can run E2FS-CK, and we can also use debugfs, for instance. As you can see here, I am listing the content of the Vault directory with debugfs. This is an encrypted directory. Debugfs does not try to print the file names because it knows that the files are encrypted and their names may contain unprintable characters. But we can start the files with the inode numbers. And as you can see, there is the LDiskFS encrypt flag. There is also the encryption.c extended attribute. And here in the link EA attribute, normally you have the name field that contains the file name. And here debugfs escapes the name so that there are only valid characters in it. So now I propose to go for a demo to illustrate how this works. In this demo, you will see how to upgrade an encrypted directory that was initially created with 2.14. I will show how to migrate and mirror encrypted files. And we will also have a look at subdirectory mount of an encrypted directory. So please make sure you enable full screen mode so that you can watch this demo comfortably. I am now going to switch my display to share my screen. Okay, so hopefully you can see a terminal. So this is a pre-recorded video that I am going to comment live. We are running on a Lustre client. It's a Red Hat 8.3, CentOS 8.3, sorry, with a 4.18 kernel. So this file system was initially formatted with 2.14. I created an encrypted directory on this file system, and then I upgraded to 2.15. So as you can see, in this Vault directory, the names are not encrypted because it was created with 2.14. We can unlock this encrypted directory. And of course, we can have access to the files that were encrypted in this old format. We can also create new files in this old format directory. But now, if we lock the encrypted directory and list its content, you can see that the name of the newly created file is not encrypted. That is because the policy was stored on disk initially when the directory was created, and this policy does not use encryption for names. So the way to convert this directory to the new format and have benefit from file name encryption is to create a new encrypted directory. So we can use the same protector. It means the same master password, but it's just that the policy will be different. And then you have to copy the content from the old directory to the new directory. It will re-encrypt everything. So of course you have to do this when both directories are unlocked. And here you can see that the names in the new directory, so this is created with 2.15, the names are encrypted, and of course we can have access to the content of the encrypted files. So now let's play with file migration and mirroring. So here I am creating a file on OST0. I am also creating a directory on MDT0, and I am putting a file inside this directory. Now I am listing the content of the encrypted directory with the key, and I want to lock the directory. And now, thanks to the inode numbers, we can identify the file. So this is the scrambled name of file to migrate. And without the encryption key, we are going to migrate this file to OST1. So if we check the striping information, we can see that it has been migrated to OST1. We can also migrate the directory again, without the encryption key. So let's migrate this directory to MDT1. If we check the striping, we can see that it has been moved. So by design, FSCrypt prevents any access to the files and any access to raw encrypted content without the encryption key. So what we did not modify FSCrypt for that, but we introduced inside Lustre a new open flag And when this open flag is specified, we do allow opening a file, an encrypted file, even if we do not have the encryption key. So we modified LFS migrate command so that LFS migrate specify this specific flag. And this is how we can migrate files and directories without the encryption key here. So let's unlock the directory and do a little bit of cleanup. And now let's play with file mirroring. So I am going to create a mirror from the file name file to migrate. We can see that it has two components, one on OST1, the other on OST0. I am writing new content in the file. So of course, obviously, I'm verifying the mirror, but it says that the mirrors are not in sync. So now I'm going to lock the encrypted directory. And what I want to do is to resync the file without the encryption key. So it seems to have been gone smoothly. So if we check with LFS mirror verify, we can see that it's happy. The mirrors have been synced. So again, this is possible thanks to the specific open flag that has been added to LFS mirror command. And the Lustre client understands this specific flag and lets the application open the file, even if we do not have the encryption key. Now let's play with mirror split. So if I try to split the encrypted file, it doesn't work. But if I split with the -d option, it works. And if we check the striping information, we can see that it has only one component now. So this is very important, and this is a constraint that is imposed by FScript. FScript forbids having two different files with the same encryption context. And if we mirror split without the -d option, we would create such files with the same encryption context. But with -d, which means destroy, delete the specified mirror, it is possible. Okay, so last part of this demonstration is about subdirectory mount. So now I am going to use subdirectory mount on the encrypted directory. As you can see here, all the content is encrypted. One thing that is very important is that the FScript command line utility needs its .fscript directory. This special directory for the application is holding the metadata encryption configuration that is used by the command. So what we do is that we virtually present the .fscript directory at the root of the mount point. Internally, this directory is stored at the root of the Lustre file system. But if we access this directory explicitly, it will be virtually presented. And so if we unlock the mount point, it works. And we have access to clear text names and content. So this feature is very interesting if you want to present your clients with only encrypted content. Okay, so this concludes the demo. Let me switch back to the presentation. Okay. So what are the current limitations of the client-side encryption? The first one is fit to pass. Fit2Pass does not work on encrypted files because the full path is built on server side, and server side is not aware of client encryption. Also, client encryption does not work with Lustre HSM or backup, for instance. One possibility would be to archive files with the encryption key. It means in clear text, but that's probably not what you may want for encrypted files. Without the key, we would need HSM agents to use the specific open flag that I was mentioning earlier, which is named OFileEnc. And we would also need to have a special mechanism to retrieve the clear text file size, which is different from the encrypted text file size. So what is not client encryption? Please remember that client encryption is not an access control mechanism. This is not because your files are encrypted that you do not need to set proper permissions on your files, and possibly ACLs as well. And also remember that client encryption does not protect file metadata. By design, this is imposed by FSCrypt. Size permissions, timestamps, extended attributes all remain in clear text on encrypted files. Now let's switch to current work in progress and talk about performance. Initially, I saw a 30% performance drop in sequential write and a 20% performance drop in sequential read. So I wanted to try again those benchmarks with a new test bed. So you have the description here. The main differences are it uses a newer CPU. Client runs on Ubuntu 20.04 with a 5.4 kernel, and it runs Lustre 2.15. Let's have a look first at the write bandwidth performance. Here, the blue bar is the performance when encryption is not involved. The orange bar shows the performance when we are using encrypted files with the current code as landed in 2.15. So you can see that we have a 20% performance drop. So this is good news. This is better than my initial benchmarks. And it's probably due to the fact that clients have a more modern CPU, and also that it's also linked to the fact that we are running 5.4 kernel on client side. But it's not still satisfying. I wanted to try different things. So this is why I hacked the FSCrypt code. And in gray, you have the performance for a code that I named void encrypt. So in this version of the code, we are doing the normal FSCrypt processing, except that we do not end up encrypting content. It's just like a no-op, and we keep clear text content. And the yellow bar is another version of the code where we proceed. So it's called no bounds, and here we proceed with in-place encryption. So it means that we do not have to allocate additional pages to hold encrypted content. Everything, the encrypted content is put in the same page. So as you can see, this is this in-place encryption that gives the best results with those different versions of the code. So it means that there is something to do with a page allocation. So I wanted to try an optimization that consists in leveraging the ENC pool mechanism. So the ENC pool is an already existing mechanism in Lustre that is used for GSS support. And basically, pages are allocated ahead of time. They are put and made available through this pool, and the size of the pool can grow or shrink depending on its usage. So I modified the FSCrypt API so that it can take a new input parameter when we want to encrypt. And this new parameter is the page that we have allocated on our own And so it avoids FSCrypt. It prevents FSCrypt from allocating its own page for every call to the encryption primitive. For 4K IOs, you can see that we have a 15% performance drop, which is better than with the normal FSCrypt code. And it's the same performance level as with in-place encryption. With 1 megabyte and 16 megabyte IOs, we have a performance drop between 5 and 10%. So this is much better here. This is not exactly the same level as with in-place encryption, but that's mainly because with encpools, we still have to manage the pages in the encpool. So it's not exactly as if we were doing in-place encryption. Now let's have a look at the read bandwidth performance. Here we have a performance drop of less than 10%. The optimized code does not show any benefit, and it's expected because in read, FSCrypt already proceeds to in-place decryption. So there is no bounce page involved here. Now let's have a look at metadata performance. We can see around 5% performance drop in the three cases: create, stat, and remove. So this is pretty satisfying. And again, there is no difference with the optimized code in green here, because with metadata, what is at stake is the encryption of file names. And this implementation does not use, the FSCrypt implementation does not use bounce buffers. So this code for bounce page allocation has been pushed to Gerrit. It's only available for the embedded LLCrypt library. The reason is we are modifying the FSCrypt API so that we are able to provide this page that comes from the encpool instead of letting FSCrypt allocate its own for every call. So we are working with James Simons to push this modification to the upstream community so that we can benefit from this performance boost when using the in-kernel FSCrypt. Another work that is currently in progress is about compatibility with newer kernels. Currently, Lustre is compatible with in-kernel FSCrypt from Linux 5.4. And this kernel was the one that was shipping with Ubuntu 20.04 initially. The thing is, kernel changes fast in Ubuntu. And so it's hard for us to keep up the pace. And the most difficult part is that even if FSCrypt API is changing upstream, Lustre needs to support all the kernels, like CentOS 8, for instance. So we still have to maintain a thin shim inside Lustre for compatibility with all those different versions of the API. We've been working with James Simons to support the FSCrypt API from Linux 5.8. So that's a patch in Gerrit as well. Okay, so as a conclusion, we can now say that Lustre 2.15 is fully compatible with FSCrypt. We are providing encryption of file content and also file and directory names. But remember that client encryption is not an access control mechanism and does not protect file metadata. And it has its current limitations, especially regarding archiving and backup. And for the record, I have put here a summary of the performance results I got. And that's all for this presentation. I hope you have fun encrypting files and be aware of the impact that encryption can have on users, on even admins' workflows. Thanks.
Thank you, Sebastien, for this great presentation. So You can all post questions to the live Q&A or the chat. So we have a more comment than a question from Michael Aguilar. It appears that the FS script is intended to be interactive. Can you comment on that, Sebastien?
I'm not sure what it means. So yeah, as I showed in the demo, the FS script command line utility will let you decide which directories to encrypt and how. And so I haven't, actually, I haven't demonstrated the whole procedure, I mean, from scratch, because the directory that was used in my demonstration was already created with the Lustre 2.14 version. But yeah, you can decide which directories to encrypt and how, and also by how I mean with which protector. So you can use a password. You can use a row key. You can even use PAM. So there are plenty of possibilities with this tool, which is not provided by us. This is a tool that is made by Google.
Okay. There is a follow-up question from John H. Do you mean that it reads the passphrase from the TTY?
Yes, I mean you input your password inside the terminal. Yes.
But as you said, there are other ways of providing.
Yeah, absolutely. I mean, if you really want to be serious about encryption, you might want to use a row key that is, for instance, stored on a USB stick or any other a card or something like that. That looks more professional, let's say.
There is another question from Michael Aguilar. Is there different levels of poly instantiation? If you know what that means.
No, I'm sorry, I don't know what this means. Can you elaborate a little bit, please?
Or intention to put that in.
So basically, what I can say is that we are not reinventing the wheel with this implementation. So the FS script API is coming from the kernel, and this API is using the encryption mechanisms that are already in place in the Linux kernel. So we are not redeveloping our own encryption algorithms or implementations. And this is the same for FS script. We want to remain compatible with this tool. So every algorithm that is available in the, or every encryption possibility that is made available through the Linux kernel can be used through the FS script API.
So Sebastien, I have a question myself, might be a bit borderline, but I really appreciate that you showed that we can use some subdirectory mount on an encrypted directory, because I see possibilities with that of exposing encrypted directory to users. Do you know if there is any work done or of if exporting this directory then with NFS over NFS is supported? Can the end user, could the end user in that case use FS script on an NFS client?
That's a good question. I haven't tried myself. I mean, when you use the FS script command line utility, it actually sends IO control commands to that are interpreted by Lustre. So I'm not sure if you run those commands on top of the NFS client mount, if these IO control commands will end up being interpreted by Lustre, or maybe they will be intercepted at the NFS layer. In this case, that would not work. So that's interesting, but I haven't the answer.
Okay, thanks. So we have a comment from Andreas. Polyinstantiation in computer science is a concept of type being instantiated into multiple independent instances. So maybe a question is whether there can be multiple directories with different keys and or multiple keys for the same directory.
Okay, so I can certainly comment on that. You can definitely, so when you decide to, so basically the workflow is the following: you create a directory and then you use fscript encrypt and the name of the directory. And here it's going to ask you about the protector that you want to use for this directory. So here you can use an already existing protector, or you can specify a new one. So you can definitely have different directories on Lustre that are encrypted by different protectors and different kinds of protectors. So one with a raw key, one with a simple password, for instance. And you can also have multiple protectors for the same encrypted directory. So that's very useful if you have a shared directory. So you have multiple users using this directory, and you do not want them to use and share the same password, because when you start sharing a secret, it will not stay a secret for a long time. So with fscript, we can definitely have different protectors for the same encrypted directory. That's possible because actually when you specify, for instance, a password to protect your encrypted directory, this is not this password that will be used as the master key. In fact, the password you input will be used for key wrapping. And in fact, you are just wrapping a master key that is generated by fscript itself. So this is why you can have different protectors. And in the end, there will be different ways of wrapping the same master key. And this is how you can have multiple protectors.
Thank you. Awesome. Well, if I want to resume to summarize and you can just read the doc about fscript, because everything should be supported, right? It's using a standard tool.
Yeah, and if not, please let us know.
Okay.